Hey, it's Mr. Estrada here, and in this video we are going to prove two triangles congruent using the side, side, side and the side angle side method. But before we do that, I do want to go over some definitions. So the first one I want to go over is the angle bisector definition. And an angle bisector divides an angle into two congruent angles. So for example, if we are told that DB bisects angle ABC, we are supposed to get from that angle ABD is equal to angle CBD. The next one is the midpoint definition. So the midpoint of a segment is the point that divides the segment into two congruent segments. So here, for example, if we are told that M is the midpoint of XY, then from that we're supposed to say that XM is equal to MY. Or congruent. Equal, congruent, we can use those interchangeably. The next definition is a segment bisector. So this is not like the angle bisector. This is a segment bisector. And a segment bisector is a line, segment, or ray, or plane that intersects a segment at its midpoint. So if we are told that CD bisects segment AB, from that we're supposed to get that AM is congruent to MB. So a segment bisector basically creates two congruent segments as opposed to the angle bisector that creates two congruent angles. So there is a difference between the two. And then we got perpendicular lines. Perpendicular lines are lines that intersect and form right angles. The symbol that you see right over here means is perpendicular to. So here it says CD is perpendicular to AB. And from that, you're supposed to get that angle CHB is 90 degrees. And so will CHA be 90 degrees, AHD, and BHD. So if you're told that you got perpendicular lines, from that you're supposed to reason that you have right angles. All right, so those are some basic definitions. Here's the first proof I want to go over. And it says that so we're given some information. So with every proof that we work on, there's going to be a given part and then the proof part. So what I like to do is I like to take the given information and label it in the diagram. So that's how I begin my proofs. I take what's given and I label it in the diagram. So I'm given that RG is congruent to RH. So that means that this segment is congruent to this segment. Then I'm also given that S is the midpoint of GH. So what can I reason from that? Well, if S is the midpoint of GH, then that means that GS is congruent to SH, because a midpoint creates two congruent segments. And then finally, and I probably should have mentioned this first, is that I do have a reflexive property here. RS is congruent to RS. So what am I trying to prove? I'm trying to prove that these two triangles are congruent to each other. And by looking at the marks in the diagram, you should be able to tell that you can use the side, side, side method to prove that the triangles are congruent. So let's actually write out the proof. Now this is called a two-column proof. So we have two columns. The left column says statement. The right column says reason. And I'm going to begin by writing the given information. So my first statement is just the information that's given. And so I could say RG is congruent to RH. S is the midpoint of GH, and I can say all that because it's given. So in a proof, you always want to back up your statements. You want to be able to justify them. All right, next, what else did we say as we were labeling the diagram? We also said that GS is congruent to SH. Remember right over here, we said GS is congruent to SH. Now, what was our reason for saying that? Our reason was that S is the midpoint of GH. And so that's why we were able to reason that GS is congruent to SH. What else did we say? Well, we also said that segment RS is congruent to segment RS, and that's by the reflexive property. And so now you can see in our two-column proof that we have enough information now to conclude that these triangles are congruent. We have proven it. We've proved it in our two-column proof. We've shown that 3 corresponding sides are congruent to each other, so then we can say the triangles are congruent to each other by the side, side, side method. So side, 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 congruent to side, side, side. All right, so to summarize, we were asked to prove that triangle RGS is congruent to triangle RHS. So we were trying to prove that the triangle on the left here is congruent to the triangle on the right. And we went about it by labeling the given information. Then we took the midpoint here of S, and we used that to say, we used S being the midpoint of GH, we used that to say that GS is congruent to SH. And then we used the reflexive property. And then that was enough information, right, to prove the triangle is congruent by the side, side, side method. All right, so example 2 says, given BD and AE bisect each other, prove the triangle ABC is congruent to triangle EDC. So again, in my method, I like to just take the given information and label the diagram. So let's begin by saying that these two angles are congruent. Now, even though that's not given, even though this is not given, we can say that these angles are congruent because they are vertical. Next, using the given information, BD and AE bisect each other, we can say that AC is congruent to CE. And we can say that BC is congruent to DC. And the reason we can say that is because these segments are bisecting each other, which means they're going to intersect at their respective midpoints. So after you label the diagram, it makes it easy to see that you can prove these triangles are congruent by using the side angle side method. And you can see it here, side congruent to side, angle congruent to angle, side congruent to side. So all that's left for us to do is just write our two-column proof. And it's just basically making everything that has a mark a statement and then back it up with a reason. So I like to just begin by restating the givens just to get the ball rolling. So we're given that BD and AE bisect each other. I make that a statement and the reason is given. So then after that, just everything that you put a mark on is a statement. So I put a mark on AC and CE. And now, what's the reason? Why did we say AC is congruent to CE? Well, because of the bisectors. They bisect each other. But for us to say AC is congruent to CE, that has to do with BD cutting AE into two equal parts. So that's why I wrote BD bisects AE. And then we also said that BC is congruent to CD, and then that would be the other way around, right? That would be because AE bisects BD. And then you remember the other thing that we said, what I actually started it off with? We also said that we have angle ACB congruent to angle ECD, and that's because they are vertical angles. And then finally, we are ready to conclude that these triangles must be congruent to each other by the side angle side method. So just to summarize, begin by labeling the given information, or if you have vertical angles, label the vertical angles, or if you have a reflexive property, label that. In this case, we had the vertical angles, So you label that, then you label the information that's given, or the information rather that you can conclude from the given. So we were able to say that AC is congruent to CE, BC is congruent to CD because of these lines bisecting each other, which essentially means they intersect at the midpoint of each other. All right, so that concludes this proof. I hope this video helps. Take care.